Just work through some more examples of using Gaussian elimination with back substitution in order to solve a system of three equations or three unknowns. So remember, the legal operations we have, we can switch any two equations because rearranging equations won't affect the solutions. We can multiply or divide both sides of a non-zero constant because we know if we have, well, do that to a single equation. If we have an equation and we multiply both sides by a non-zero number, we'll still have the same solutions. The equation will just look a little bit different. And we know that you can add the same thing to both sides of an equation or subtract the same thing from both sides and it won't change the solution. So we know in particular we could add or subtract a multiple of one equation to, or from, in the case of subtraction, another equation. So just using those legal operations, we try to get to a stair-step form called echelon form. Once it's an echelon form, then we'll have the bottom equation will only involve one variable. We'll read off its solution. Plug that in here so that the next equation up only has one variable. Solve it and get its solution. Plug those two up in here so that the first equation only has x in it. Solve for x, and then we're done. So looking at this, I can see I could take 1/2 of the first equation and subtract it from the second and also from the third to make the x's disappear, but that would require me to work with a fraction. So just for ease of computation, I'll probably switch equation 1 with equation 3. Here's a little notation that I make. You might try to pick up this habit as well so you can remember what you did. Here's a little notation for what I'm doing here. I'm just switching equation 1 and equation 3. So negative 4y plus 5z equals 1, and then we have our second equation, which we haven't messed with, x plus y minus z equals 1, and now our new third equation came from the top, 2x minus 3y plus 4z equals 3. Have the same information, it's just listed in a different order. The solution must still be the same. But in that form, I can easily see that if you just subtract equation 1 from equation 2, or add the opposite of equation 1 to equation 2, that'll give you a nice equation 2 without an x in it. You can also take negative 2 times equation 1 and add it to equation 3, and that can give you a nice equation 3 without any x in it. So let's do that. Notice here we're only changing equation 2 and equation 3. So nothing's wrong with what I'm using for my equation 1 right now, which is x minus 4y plus 5z equals 1. If I subtract the first from the second, take negative 1 times the first equation and add it to the second equation, x minus x is nothing. We kind of planned it that way. Y minus 4y is 5y, and negative z minus 5z is negative 6z, and 1 minus 1 is 0. Okay, and also we're going to take negative 2 times equation 1 and add it to equation 3 to get the x's to drop out there. So negative 2x plus 2x is nothing. Negative 2 times negative 4y is 8y, plus negative 3z makes 5y. And negative 2 times 5z is negative 10z, plus 4z makes negative 6z. And then finally, let's see, negative 2 times 1 plus 3 makes 1. Okay, so I'm on my way to having a staircase. I just need to carve out a step right here, and I'll be good. I can do that by taking negative equation 2 and adding it to equation 3 to get a new equation 3. So recopy my first equation and leave my second equation alone as well, but then subtract the second equation from the third equation to get a new third equation. 5y minus 5y is nothing. Negative 6z minus 6z is negative 6z plus 6z. That's nothing. Uh-oh, because 1 minus 0 is 1. You can see that we ended up with something that's never true, which basically means if equation 1 and equation 2 are satisfied, then it's impossible to satisfy equation 3. So there's not going to be any solution. This one is inconsistent. Let's do another one. Solve this system. Again, I think I would like to switch equation 1 and equation 3, so I could work with this x, which I call it my pivot. If I send that up, it would be easier to work with that pivot, especially since I'm doing the multiplication by hand. Okay, so happy with equation 2, so just recopy it here. I'm keeping a system together at all times. This helps me be, well, systematic about it as I work through. But it's easy when you have three equations to three unknowns to solve for one thing, and then if you're using like substitution, you could plug it in, and then you'd find another thing, you'd plug it in, but you might end up going in circles. So this Gaussian elimination is just kind of a fast way, and it prevents you from going in circles. You can see what I need to do in the first step of Gaussian elimination is to eliminate all the x's before that top x, and that can be done by taking negative 3 times equation 1 and adding it to equation 2 to get a new equation 2. I could also take negative 5 times equation 1 and add that to equation 3, and that would make a nice equation 3 that wouldn't have an x in it anymore. When I do that, I get this system. Let's see, I'm not changing the first equation, so I'll just copy that down. Oops, it's supposed to be minus 3z. That's going to cause trouble. Minus 3z equals negative 6. And I'm taking negative 3 times the first and adding it to the second. So negative 3x plus 3x is nothing. Negative 3 times 2y would be negative 6y plus 5y is negative y. And negative 3 times negative 3z would be 9z plus z would make plus 10z. And negative 3 times negative 6 is 18 plus 1 makes 19. At the same time, I was going to take negative 5 times equation 1 and add it to equation 3 to get a new equation 3. So negative 5x plus 5x is nothing. Negative 5 times 2y is negative 10y. Add that to negative y and you have negative 11y. Negative 5 times negative 3z would be plus 15z. So, and 15z minus 2z would be plus 13z. And this last one, I need to do negative 5 times negative 6, which is positive 30, and add that to this negative 15, which just leaves me 15. Okay, well, now I can see how to eliminate this y. If I take negative 11 times equation 2 and add it to equation 3 to get a new equation 3, I'll be in echelon form. Okay, I'm not changing my first equation, which is x plus 2y minus 3z equals negative 6. I'm not changing my second equation, which is negative y plus 10z equals 19, but I'm making a new equation 3 by taking negative 11 times the second equation and adding it to the third. So what we'll get, let's see, negative 11 times equation 2, negative 11 times negative y makes 11y, plus negative 11y, and the y's cancel. That's good. Negative 11 times 10z is negative 110z, but we add 13 to that, and we get negative 97z. And let's see, negative 11 times 19, let's see, what would that be? Negative 11 times 20 would be negative 220. So, but we're 19 short there. So, or we're 11 short. Let's see. Yeah, we're 11 short. So that would be negative 209. And then we take our negative 209 and we add 15 to it, and that makes negative 194. Okay. Now you can see we have our staircase, and so we can solve for z. Z is negative 194 divided by negative 97, which reduces to 2. So now we know z is 2. We can back substitute into the next equation up. Negative y plus 10 times z would be 20, because z is 2, equals 19. So negative y equals negative 1 when I take 20 away from both sides. So y is equal to 1. Finally, knowing that z is 2 and y is 1, we can go up to the first equation and back substitute in there. X plus 2 times y, but y is 1, so 2 times y is just 2, minus 3z, z is 2, so that's minus 6, equals negative 6. If I add 6 to both sides, I get x plus 2 equals 0, so x equals negative 2. So I found my solution. X equals negative 2, y equals 1, and z equals 2. Sometimes that solution will be written as an ordered triple. This is a point in space where all three of those planes intersect, so the point negative 2, 1, 2. It's a good idea to check because it's easy to make an arithmetic error when you do this. If we check in the first equation, we have 5 times negative 2, that's negative 10, minus 1 is negative 11, minus 4 is negative 15, so it works in the first equation. You need to technically check each equation. So if we put in negative 2 for x, 1 for y, and 2 for z in the second one, we get negative 6, plus 5 is negative 1, and negative 1 plus z would be negative 1 plus 2, that's 1. So the second equation also has negative 2, 1, 2 as a solution. And the third equation, what about it? If I plug in negative 2 for x, I get negative 2 plus 2 times 1 would be 0, and then negative 3 times 2 is negative 6, negative 6 equals 6. Yeah, so this point lies on all three planes, so we've correctly found the solution.